So what my talk is really about is managing a DBT project that is growing and growing fast. And I titled it The More the Merrier, because even though it doesn't feel like it sometimes, it is generally a good thing to have more contributors to your project and more models appearing in there every day. So my name is Alice Leach. I'm a data engineer at Whatnot. I've been in the data space for just over 2 years now. I transitioned from a career in academia, like many of us, in 2021, and I've been a DBT user since 2021. Outside of data, I very much enjoy pizza and beer, so San Diego's been a real treat for me with all the breweries floating around. And I also love 3D printing, so if anyone wants to nerd out about filaments later, come and find me. We can have a great chat. So I mentioned I work at Whatnot. What on earth is Whatnot? Well, Whatnot is a live stream shopping platform. So what that means is our sellers, and that could be any one of you, hop onto the app and they go live. They start filming themselves, they start filming their products. Our buyers log into the app, they chat, they react, and they bid on the products that our sellers are selling. We've been named one of the fastest growing marketplaces in the US 3 years in a row, and we now operate in over 100 categories. So that's Whatnot, but what you guys are really here for is DBT. So what does DBT look like at Whatnot? Well, we're Snowflake-backed, and we have probably about 1,200 models right now. We had 1,160 at the beginning of October, but I've been away, so I think we'll have had some more sneak in. And that's about 4 times growth in the last year. So we had about 250 models at this time last year. We have about 21 billion records in our largest table. And our DBT project primarily supports analytics and machine learning workflows, as some of this data is also served back into the application. In terms of usage, we have 2 DBT-focused engineers, and we operate as a self-service project. So we have 70 developers who've made contributions to the project, and about 30 of those are what we consider active, which means that they contribute at least once a week. We see about 10 PRs a day on our project. And that project supports what we call our DBT database in Snowflake. All 450 employees at Whatnot have read-only access to that database in Snowflake. And we see about 300 queries a day against the DBT project data from individual users. So that's things outside of our dashboarding tool and our DBT project itself. So what does our DBT project look like? Well, it's actually sneakily 3 DBT projects. So we have our events DBT project, and these are all auto-generated staging models that sit on top of our event log data. And then we have our CDC DBT project, and that is auto-generated staging models that sit on top of our CDC ingested data. And those are referenced as sources in our primary DBT project. We have 5 schemas inside that DBT project, and the color scheming there is not just for your visual pleasure. It's also because the darker gray schemas were the ones that we've had all along. So we had applications, which is a light transform layer that sits on top of our sources. And then we had products, which is marted models that are generally built and maintained by our stakeholders. And then we have the project schema, which is for sandbox-style work. Developers can try things out there with minimal CI. So after we'd worked with these for about a year, we decided that we needed more here. So we inserted the core schema, which is a Kimball-inspired dimensional modeling layer. We wrote a blog post about the decisions behind this about 6 months ago, which I would encourage anyone interested to check out. But it basically pulls some of the logic that was inside the products back into a centralized location. And we also inserted a visualization schema. These are just denormalized models that are intended to optimize performance in our BI tool, which in our case is Sigma. So we have our nice tidy project structure. How do we orchestrate? Well, our events DBT project is incremental and runs every 5 minutes. Our CDC DBT project is made up of views, and these will run on merge to main when there are changes. And then our primary DBT project, we build based on priority and cadence. I will say that this is a work in progress. I was hoping it would be finished by Coalesce, but we're still detangling a couple of our dependencies. But essentially, we give each model a priority, Our P0 models can be built minutely, hourly, or daily. And these have a full suite of CI that goes on them, and they must meet our build time SLAs. Typically, they'll support critical models, so user-facing or critical dashboards that, for example, our CEO is looking at. We then have P1, which supports any kind of in-use day-to-day data products that are shared between many departments. We would expect error response to a P1 model within days rather than within hours for a critical model. And these can be built hourly or daily. And then we define things as P2 or less criticality. These are supporting temporary or ad hoc analyses. There's no required error response, and these are on an ad hoc cadence. So anyone can go into our orchestration tool, hit build, and build the model that they want in production. So if we've got a beautifully tidy project and a planned orchestration system, what's the problem? Well, I can tell you there are many. And amongst the biggest ones that have come up in the last year, we've hit against a lot of long-running queries, not only due to inefficient SQL, but also due to the fact that our data sets have expanded significantly. So things that might have taken 5 minutes to build a year ago are now taking 5 hours to build. We also have some pretty complex model dependencies, and these can also be nonlinear. That's a particular issue associated with the fact that we inserted our core after some products had already been built. So because of that, we've seen a lot of cascading model failures. So when models fail, things that we least expect might end up being downstream from those models. We also have some pretty rapidly evolving source data. Our software engineering team is fabulous, but they change things, and they change things quickly, and they change things a lot. So the data that came in yesterday may not be the same as the data that comes in today, and we need some guardrails to protect for that. And then finally, because we're self-service, and we have a lot of developers, we've seen some project bloat. So there's a lot of things in there that we don't necessarily need. So I'm going to talk a little bit today about how we've combated those pain points. I would say we're by no means there. There's a lot of work still to be done. But we've tried our best, and here are some of the techniques that we've used associated with that. So I'll break them into the 3 Gs. Guardrails, which is things we're trying to do to prevent people from doing incorrect things. Guidelines, which are suggestions we make to follow best practices. And then gadgets, which is any automation that we've put in place to prevent people from doing repetitive tasks. So guardrails. I think when a lot of people hear guardrails, they immediately think CI, and so did we. So we break our CI into 3 critical sections at Whatnot. The first is, does the model run? And that is Slim CI. I've been to a number of fabulous talks at the conference about Slim CI, so I'm not going to dwell on it. But essentially, you're running just the modified models in the PR to make sure that they don't break your build when you push them into production. We then have conventions. That is, are the project requirements met? In our case, that means we want to know if a model has a maintainer associated with it. We want to make sure that the model dependencies are compatible with our orchestration setup and our schemas. And we also want to make sure that basic DBT best practices are met. For example, no hard-coded references. We want to make sure the model name fits our convention, and that any critical model has associated tests like unique and not null. Finally, we have our linting CI. And I've written, is the model readable there? But it's really more like, is the model legible? So we found for linting, less is more. I have 70 developers, and they all have different opinions on how SQL should be written. I have found that it's best not to fight them. So we've narrowed it down to things that we would deem absolutely critical. So I don't mind if you're a leading comma or a trailing comma. What I mind is how long your line is so I can read it in GitHub, and critical things like aliasing and capitalization for the names of fields, and that's mainly for the purposes of keeping things uniform inside of Snowflake. So critical for CI, and the thing we receive the most feedback on, are keeping the lines short. CI must be fast, it must only run things that the developer has touched, and it has to run parallelized. Otherwise, you will get complaints, and it will be very sad for you. So to talk a little bit about that, we'll touch on Slim CI. DBT has come out with some fabulous changes in the last few months that have really helped with the the fast and the parallelized. I'm sure many of you are familiar with the state-modified argument and the fact that you can now defer your CI to the environment rather than to the run. But for us, until the environment deference came in, we were deferring to a run, and we learned a lot about said run. First of all, because we have so many pull requests going in a day, you absolutely have to refer to a run that was run on merge to main. But instead of building models, because they can take some time, we just ran a dbt compile because that took less than 4 minutes. And so we were able to get the most up-to-date state of the repo immediately. The other thing that we've learned is that when you have many pull requests a day, not all of your developers are going to merge from main prior to putting out their pull request. And if they don't do that, state modified will run everything that has changed, including the last 9 PRs that went into the repo, and then they'll complain to you. So what we've done is we've blocked CI from starting until the developer has merged from main into their pull request. You can't actually do that with the cloud CI right now. So we're using a package called dbtc, which was built by Doug Guthrie, who's a solutions architect at dbt. He's fabulous. But it allows you to block those pull requests until the developer has merged from main. The other thing I'll mention real quick is flags are your friend in CI. Particularly, I want to highlight fail fast and warn error. These are elaborated on in various dbt discourse posts, but fail fast will stop the run immediately upon a model failure. The developer's going to have to fix the failure anyway and then rerun everything. So you might as well kill the build immediately, give them the feedback quickly, instead of wasting time building models that you'll have to build again. The other thing that I will suggest turning on is warn error. We had this off. We ended up with 64 warnings in a list on every dbt compile. And it was extremely unpleasant and meant we had a number of widowed tests and things in the dbt project YAML, so widowed pathways in the dbt project YAML. Turning on warn error, it annoyed people, but it meant that that noise was eliminated and people take those warnings a little bit more seriously and have a better understanding of how the YAML and the SQL talk to each other. The last thing which we've done is we actually time out our stage runs. The big life lesson here, which sounds obvious but was not immediately obvious to me, was that if it takes a long time in stage, it's also going to take a long time in production, and you probably don't want that. So we time out our CI runs, and we also heavily suggest that if you're timing out in CI, you consider incrementality or you rewrite your SQL. I will say we also use minimize dev table size. So if people need to, they can add that macro to their production, to their model. And then in stage and in Scratch, it'll only run the last 7 days of data. And this allows people to get through CI. So it's not a cure-all, but it is quite helpful to give them immediate feedback that this is not normal and your model shouldn't be taking that long. Parallel runs and canceling PR on update is something that dbt has implemented recently. I remember having a conversation with people this time last year about my infinitely queuing stage runs. And this has eliminated a lot of the needs there. But just know that if you have long queues in your CI, no one's going to wait for it, and they'll find a way to merge in anyway. So very important. The last thing that I wanted to mention when it comes to CI is that incremental models will cause bugs in your CI. There is the on-schema change argument, which allows you to address things like new columns. But if anyone's used this ginger inside the incremental model, it's going to break. There are 2 workarounds we use for this. First of all, we provide a whitelist. Anyone could add their model to the whitelist, and it won't run in CI, but it will be sent to a data platform team member for review. So we get an extra pair of eyes on it. And then the second thing we do is we provide an operation for developers to alter the table as needed, so things like adding and dropping a column. That allows them to do that in stage. The CI will then run successfully, and they're going to have to then do it in production into the incremental model anyway. So it allows them to kind of practice it in the stage environment first. So a little more on our conventions. Conventions are basically just ensuring that people meet DBT's best practices. And perhaps the best tool for that is the DBT Project Evaluator. It's extremely comprehensive and extremely useful. However, we found it to be a little bit too opinionated. I can't tell you how much feedback I got that they firmly believed that they did not need to meet all of these best practices. So for that reason, we've actually switched to using a combination of DBT checkpoint, which was previously known as pre-commit DBT, and some custom CI tests as well. So DBT checkpoint we use for things like hard-coded references, making sure model name requirements are met, and they're pretty customizable. I will say we've experienced some test failures when they shouldn't have been met, and tests that pass when they should fail. So you need to be really careful in the way you set up DBT checkpoint tests, but they're generally extremely useful. Our codes are fabulous because they're completely built for our unique project. We use them to check that every model has a maintainer and that our lineage requirements are met so that things don't break in orchestration. We can also optimize these for performance, so they run pretty quickly. We've had some experiences where the convention CI really slowed down, so filtering these to only necessary schemas has been really helpful. But you then have to write them and maintain them yourself. So it's nice to be able to use the packages because you can get these set up in 30 seconds and immediately have tests. So changing gears a bit, the final guardrail that I wanted to mention was our cleanup processes. So a lot of you may be familiar with the fact that DBT does not drop models in the data warehouse that have been dropped from the project. And there's a macro that you can add to your project that handles this. We have that in place. It runs weekly. It will post a message to Slack pointing out the models that it intends to drop. You have 24 hours to review that. Next day, they're dropped. It's been fabulous. I think we've dropped hundreds, maybe thousands of models at this point. And we'll typically have 10 to 20 a week being dropped out. But the thing that that test does not do, or that macro does not do, is tell you what models exist in your DBT project that just aren't being used. We have 1,200 models. I'm pretty sure a lot of them aren't being used, so we decided to check in on that. And we do that in two ways. We have a development environment where our developers can create tables and alter them. We look at that environment, and we see if a table has been altered in 90 days. In our production environment, we'll take a look at the Snowflake query history, see if a table has been queried in the last 90 days. If it hasn't, it goes into a monthly Slack digest, and we will notify the owners and ask them if we can deprecate that model. For the development schema, we actually drop them automatically after 5 days because the developers know how to rebuild them. So why not? So moving on to guidelines. And when you think of best practices, the natural next step is to think documentation. And all of us know that it's important to keep good and up-to-date documentation. I'm not going to dwell on it much other than to say that we've decided that it's best to keep as much of it as possible as near to the code as possible. So we keep the bulk of our documentation in the repo. For our general users, that's through the DBT docs and YAML. For our developers, we use the README. The reason we've done this is to keep it as dry as possible, so prevent repetitiveness. Also to know where it needs to be updated, only in one spot. And then finally, just to make sure it's accessible to everyone, we assume that if you're developing against the project, you have access to the GitHub repo. So you definitely have access to the README. And for our users, we make sure we serve the documentation and keep it accessible to everyone in the company. So our next guideline is that we want to keep a modular workspace. What that means is we provide templates to all our users for models and YAMLs. So I will say the CodeGen package, DBT CodeGen, does a very similar thing. We've just taken the DBT CodeGen package and made some modifications to fit our use case. But we actually use a makefile to define the commands to copy or clone the template folders into the right workspace with the right name. So for example, if a developer types make data mart, it will copy the templated model and YAML file into the appropriate products and projects folders, and immediately add a mark maintainer in the project YAML. So I think long term, we'll probably move out of the makefile model and into a dbt macro. We are cloud users, and at the moment, we can't run the make command in cloud. So long term, we'll probably move to a dbt macro, but the makefile has been really useful for us so far. The final guidelines that I wanted to touch on are macros, because really, when you think about macros, when you think about reusable code, that is a great place to define best practices and then encourage your developers to use those. And we really have three groupings of macros. We have dry SQL, so any SQL that's repeated heavily in the repo. For us, that's typically where clauses. For example, look-back dates, filters, and the incremental clause. We also then have SQL functions, so any SQL that's repeated to calculate a value. A great example of that for us is currency conversion logic. We use a macro for that to make sure everyone's doing it the same way across the repo. And then finally, we have helper functions, and that's any SQL or Ginger that is used to perform an operation. So for example, our CI operations are all macros. We also include some DDL, DML command macros to kind of allow users to do operations that they might typically do in Snowflake without us knowing. A good example of that is our copy to S3 macro. I'll touch a little bit more on that in the gadgets section, but it's been really helpful to place data in the hands of software engineers who are more used to accessing it from S3 than from Snowflake. So really the takeaway here for macros is that if you equip developers with reusable code and make it easier for them to use the macro than it is to write the code themselves, it's going to save you a lot of time in the long run and allow you to modify code in one place and sneak it into everyone else's models. So as a case study for guidelines, I'm just going to touch on incrementalization. And I think the biggest takeaway that I will give for a self-service project is that incrementalization is hard, and you should consider it hard and know that many of your users will struggle with it. So what we do is we provide documentation and examples specific to our project, but we also provide an incremental macro. And we do that for two reasons. We expand upon the typical like select timestamp greater than max timestamp from this. We include a backfilling clause. We found a lot of situations where people would want to update some columns from 2 months ago. So adding a backfilling to the macro has allowed us to operate on that using vars. And then we also include a look-back window. We have some late arriving data, but more importantly, we run things on different cadences. And when there's a join in there, if you don't use the look-back window, we've experienced some issues where incremental tables don't match their kind of materialized as tables equivalent. The other thing that we've started to do is using a meta timestamp. So what that means is in our upstream incremental models, we're adding the sysdate in a new column. And then our downstream models are incrementalized based on that sysdate. What that means is that if I full refresh an upstream table, that meta timestamp column will completely update. And then the downstream models that are incrementalized upon it will pick up all that data without me having to run the full refresh operation on them as well. The last thing that I would strongly recommend if you're moving to incrementality is to build an incremental model alongside the original table and then use the dbt audit helper package to compare them over a week or a day if you're running hourly. It's been absolutely fabulous for us to pick up small issues in incremental logic and make sure that people trust their incremental models prior to pushing them into the production environment. Finally, I'll say that incrementality remains one of the biggest causes of instability in our project, and we're looking carefully at dynamic tables and materialized views as a long-term replacement in some cases. So, in the last 5 minutes, we'll talk a little bit about gadgets, which is the fun and automated part of the project. And my favorite part is code generation. So about a year ago, I spent a great deal of my time modifying our source and our staging models based on changes that software engineers made to our upstream Postgres or events database. And the fabulous team of data engineers around me got really sick of this, and they decided to build code generation. So in both our event logs and our CDC logs, we now have generated DBT based on the software engineer's definition upstream of the new event, the new table, or the updated table. So the engineers will modify the repo, we'll get a pull request to the DBT project, and we can review and merge it in. It's really saved us a lot of time and a lot of energy, and it's something that I would highly recommend considering if you deal with a lot of these requests. So the other gadget that we've debuted in the last year is macros that allow users to perform DDL, DML operations on the tables. So things like deleting rows from a table, or adding and removing a column from a table. There are two reasons that we did this. The first is that we've now got some tables where full refresh takes a prohibitively long time, and we don't always want to buy the hours on a 4 extra large data warehouse to fund their refreshing. And the second reason for that, we've implemented time travel on a lot of our critical tables, which allows us to look back at the history for 90 days. A full refresh operation is a create or replace statement and overwrites that time travel. So it's not so hot if you want to look back 5 days and you realize that that history is gone. So initially, I think people were kind of worried about this because people now have the ability in production to mess with tables. But I think what we realized is, first of all, most people don't want to do that. So they make every effort not to operate on the tables unless they have to, and they practice in the stage environment first. And then the second thing is, if they do mess it up, you are going to do a full refresh anyway. We don't mess with the source data. You can just press the full refresh button, get that giant instance, pay your money, and get the data as you need it. So this has actually been a really, really great change for us by putting that power in the hands of the developers for their own models. Finally, and I've got a little bit of time, we'll talk about unloading. So a lot of our 70 developers are software engineers, and what they want is the data in a place that they can use it, and that for them is not Snowflake, it's somewhere in AWS, so in our case, S3. So what we provided was an unloading materialization that allows them to point to the table and say, unload this to S3 at this cadence, and the data appears for them. This can be combined with either incrementality or a Snowflake stream for scalability. And it's been really useful for us not to have to deal with those unload requests and let them do it themselves. I will say put monitoring in place immediately if you choose to do this. You want to know how big the file is that they're trying to unload. You want to know how long it's taking, and you want to know how many files that they're trying to unload. People will try and unload the whole warehouse if you let them, and that is deeply upsetting. Okay, so the last thing to talk about is where we're going. I think we all know that we're following DBT, and that we're looking at thinking about semantic layer, we're looking at data mesh, we have 1,200 models, should we break up the project? But in the shorter term, we're really looking to simplify the path to incrementalization. We're looking to improve our documentation and our discovery, so we deal with less questions regarding where things are. And we're looking to improve our developer experience. We still have CI that takes longer than we'd like it to. And we still have some restrictions in place about what you can run at a 5-minute cadence, an hourly cadence, etc. So I'm going to leave you with some thoughts. The first thing that I'll say is, if you're running a self-service project, make sure you're implementing guardrails and not gates. There's always an edge case. There's always someone who needs a workaround. So don't prevent things. Just suggest very, very strongly that it should be done a certain way. Similarly for your guidelines, keep it simple. It's easy to be opinionated, but it's not always useful to be opinionated. So pick the things that are extremely important, document them well, and keep it very simple. And finally, give people the power to do what they need to do, be that unloading data, operating on data, but trust them to make the right choices, and know that because you don't touch the source data, you can always rebuild it. Finally, I will leave you with one of Whatnot's core values, which I think is very important in a self-service project, and that is to always have fun and be nice. Thank you very much. We only have 1 minute. I'm really happy to take questions, but if people need to go, please also go ahead. I'll be here for a while. Yeah. Yeah, absolutely. I also, we're writing a blog post about this, which we'll share out later, which will have the link to the actual code, as opposed to screenshots of the code, so you can copy and paste and use it as you need. Thank you. Do you have a question? Yeah.